Assalamualaikum. Hope you all are very well. I have promised to share a video with you people, which will consist of some force solutions, force resolving, and then how to find the resultant force acting in different directions. So I hope that it will help you out because when I used to teach online, some of the students could not get that. So here I would show you some forces, that how to find those forces and how to get their resultant. For that purpose, what do you need? You need a compass, then you need a scale, and then you need a protractor. So hope these are very common tools, and these tools are available with all of the students in the maths box. Okay, now let's start with that. If I have a force, suppose I have a force of 30 Newton. How much force I have? I have a force of 30 Newton, and I want to show that force, or I want to draw that force on my graph, or on my paper. So it doesn't, I on the paper I don't have any length or space for 30 Newton. So what will I do? I will scale my paper. So first step, I told you that scale your force. So scale your force means that you have to show 1 centimeter is equals to how much newtons. Okay, so here I have 30 Newton force. So for 30 Newton force, I can say that good scale is, if I say that if 1 centimeter is equals to 10 Newton, I will get 3 centimeter long vector, or 3 centimeter long arrow. If I say that 1 centimeter can be equals to 5 Newton, or 1 centimeter is representing 5 Newton, then your force will be, or your vector will be equals to 6 centimeter long. So I will just draw a force without its direction. So suppose I'm starting this from 10, and if I follow this scale 6 centimeter, then it should be reaching to 16. So I will just draw a scale, draw a line, and this line will show that length of the force, or length of the vector, is 6 centimeter, or it is basically equals to 30 Newton. Why? Because 5 newtons are equals to 1 centimeter. So this is total to 6 centimeters. So 6 centimeters are equal to this. So I have shown an arrow over there. So this is one force which is acting in this direction. Now if I have another force, that force is, this was your F1, so I have drawn F1 over here. What was that force? It was F1, and that was equal to 30 Newton. Now if I have another force, and that force is, suppose, F2, and that force is, let's say, 50 Newton. How much? 50 Newton force. So this 50 Newton force is at 30 degree below F1. I am going to give you just a simple example, starting with the simple one. Then I have to place my D over here, and I have to arrange this D in such a way that its 0 is over here and this dotted line is over here, and then I will draw a line 30. I will just place a point 30 centimeter, 30 degrees below this line. So this is the point which is 30 degree below. Now I will remove it, and I will draw a straight line, but that straight line would follow this scale because I have selected this scale. So this is my scale. That means that 1 centimeter is basically equals to 5 newton. So this is my scale. I would follow this scale, and according to this scale I would draw force over here. I hope that you will get this one. Now when I will draw the force, that force should be equal to how much? For example, if I have given you the idea that if it is 50 newton and 1 centimeter is equals to 5 newton, then this 50 newton force should be equal to 10 centimeter. Okay, this will be equals to how many centimeters? 10 centimeters. So I will put the scale over here at 10 centimeter mark. It is starting from 10. It means it would be ending at 20. So this is what a 10 centimeter long line or a vector which is 30 degree below this, and this is representing your 50 newton force. Got it? Now my next target was the next issue which the students were facing, that was whether that force is to be creating a resultant force or not. So yes, that force, that these two forces will cause a resultant force, and to find the resultant force I will adjust the compass, and then I will show you how to make a parallelogram. Actually, I'm going to emphasize the parallelogram method over here. I will place the that compass, and I will open it at equal to the length of this first vector, 30 newton, I mean 6 centimeter. Then place this at the head of second vector, I mean 50 newton, and draw an arc. Okay, I will repeat this. First, you have to open the compass equal to the length of this first vector, 30 newton, I mean 6 centimeter. Then put it on the head of second, and then draw an arc. This is an arc. Now you have to open your compass equal to the length of second vector, which is 10 centimeters. So I have opened it equal to this. You can check this one out, that I have opened this compass equal to the length of the second vector, this one. Okay, and I'm gonna draw, or I'm gonna place this compass on the head of first, and I will draw an arc over here. Sorry, that have to be fixed one at one point, and then you have to draw the arc. Okay, I will show you that how I did it. I have drawn an arc over here. I have to hold it over here. Sorry, again it is going to be slipped down. So this is the arc. This is that arc what I have drawn. So these are two arcs. Now it would be very simple to draw for me a parallelogram. I will join the head of first vector to this point where these arcs are intersecting to each other. This is your 50 newton force or 50 newton force vector, and then I will draw another vector which is basically a replica of this 30 newton. I will start it from the head of this second one, and this way it is basically your 30 newton. Now this is your perfect parallelogram. No need of uh, plotting some angles or anything else. Now you have a parallelogram, perfect parallelogram, and now the resultant would be, remember this thing, resultant's head is always to the head junction. So remember this thing, this is your tail junction. If I say this is your tail junction of the vectors, and this point where the arcs are intersecting, this is your head junctions of the vectors. Now I will start the resultant, I will draw the resultant, and that resultant would be starting from tail junction, and then it would be joining at the head junction. Okay, it is starting from the tail junction and it is ending at the head junction. Now this is your resultant. What is that? This is your resultant vector, a resultant force. Now, as I told you that I have to do, or I have to draw this resultant, and I have to determine the magnitude of that. So this is now to determine the magnitude of determine the magnitude of resultant. Okay, so when I'm going to determine the magnitude of resultant, I have to measure the length, as I have started all the length from 10 centimeter because this is my starting, and this is ending at 25.5. Check this one out. This is 22, 23, 24, 25, and this is 25.5. So the length of this vector is 25 minus 25.5 minus 10, because I have started from 10. So remember this thing, I have starting from 10 and it is 25.5. So this is basically 15.5 centimeter. This is its length but not the magnitude. So when I want find the magnitude of the resultant, that is basically, again I will use the scale. The scale is that 1 centimeter is equals to 5 Newton. So here the length of resultant is the length of R, that is equals to 15.5 centimeter. So it shows that the magnitude of R, that is equals to 15.5 times 5. So that will give me the resultant magnitude of the resultant. So I can put unit over here, so it would become 77.5 Newton probably, but I'm doing this without calculator, so there can be some mistake in it, but there is. This is basically your 77.5. Okay, this is your 77.5 Newton. So I have drawn this all. Okay, now this is basically the magnitude of that. Sorry, I am having some some instability in my camera, so I have fixed it again. Sorry for inconvenience. Okay, now I would find the direction of resultant. So to find the direction of resultant, just place your D again and check at which angle this line is passing through. So this is basically the direction of your resultant. So this is passing through 20 degree. So direction of the resultant is 20 degree. So what is direction of resultant? Direction is 20 degree below your force. So I hope this video will help you out. If you have any confusion or if you want to ask any question, you can ask me in your comment section. Thank you.